Hello everyone, welcome all to Physics with Aeronautics. So in this video we will discuss about the previous year question of cpet, that is 2024. So let's begin. And here is the question number 21. Uh, for a thermodynamic system, the relation between entropy S and the thermodynamic probability omega is, and here our options are S equals e to the power minus k omega, and S equals 1 by k e to the power 1 by omega, then S equals 1 by k ln omega, then S equals k ln omega. Okay, so we know that the Planck's expression for the entropy is S equals k ln omega, where S is the entropy, k is the Boltzmann constant, and omega here is the thermodynamic probability, or we can say the number of microstate. Okay, so here the option D is the correct one, that is S equals k ln omega. Then in the Stern-Gerlach experiment, a beam of silver atoms is passed through, and the options are a strong uniform electric field, a strong uniform magnetic field, a non-uniform electric field, and a non-uniform magnetic field. And here the correct answer is a non-uniform magnetic field. Then question number 23. Which of the following represents the Hermite polynomial h5x? And here are the options you can see. So if the general form of Hermite polynomial, that is h and x, can be written in the form of minus 1 to the power n e to the power x square dn by dxn e to the power minus x square. Okay, so here n is given as 5. So we have to find out h5x. So if we put in place of n 5, then after सॉल्यूशन निकालने के बाद जितने भी हमारे पास डेरिवेटिव आएंगे वो सब करने के बाद विल गेट द फाइनल आंसर एज 32x5 minus 160x3 plus 120x. Which is the option B? Then which of the following network theorem is the 12 Norton's theorem? Options are reciprocity, B superposition, C is maximum power transfer, and D is Leibniz. Okay, so the Norton theorem says that any linear network can be represented by an equivalent current source in parallel with a resistance, where the Leibniz theorem says any linear network can be represented by an equivalent voltage source in series with a resistance. Okay, so here the dual of Norton's theorem can be can be Leibniz theorem. So option D is the correct option here. Then a thermodynamic system undergoes an adiabatic process in a temperature T versus entropy S. Diagram S represented by the options are a straight line parallel to T axis, a straight line parallel to S axis, a straight line making angle 45 degree with the S axis, and a parabolic arc. So here it has been asking about the adiabatic process, and we know that in adiabatic process delta Q, that is change in heat energy, equals 0. Again we know that delta Q can be written as TdS. So TdS will be 0. That means here S is constant. Okay. So if you see the diagram, that is T versus S, then we can see that if S is constant, that means a single value S can have, and which will be parallel to the T axis. So the S represented by a straight line parallel to the T axis. Okay, so here the option A is the correct one. Then in a BCC crystal, the structure factor for the reflection from 111 plane each. The options are 4F, 0, 2F, and F. And we know like f HKL can be written as summation over j equals 1 to n f j e to the power minus 2 pi iota h xj plus k by j plus f j j. So for VCC crystal, the atoms are at the corner and one atom is at middle one. Okay, so it is an in the 0 0 0 plane and the half half and half. Okay, so by putting all this value here, we can get that h plus k plus l when it is coming out to be odd, then f h k l, that is f 1 minus 1 is 0. But when h plus k plus l is even, then f h k l is 12. Okay. So here the plane given h, I mean h is 1, k is 1 and l is 1. So if we'll add all these three like a 1 plus 1 plus 1, then we can get 3, which is a odd number. And for h plus k plus l is odd, here at hkl is 0. So the option B is correct one. I mean also you should know कि uh, for abscissa crystal, here H, K and L all individually should be even or all individuals should be odd. Okay, to get a reflection, otherwise it will be 0. Then if the vectors are kept f of r is solenoidal, then f of r is proportional to, सो हमें एक वेक्टर गिवन है जो कि है एफ ऑफ आर एंड उसका डायरेक्शन क्या है आर डायरेक्शन पे है ओके सो आर डैफ एफ ऑफ आर इज सोलिनोइडल एंड अगेन सोलिनोइडल में जो कंडीशन होता है वी नो दैट डेल डॉट एफ ऑफ आर इक्वल्स 0 ओके सो इन स्फेरिकल केस क्या होता है डेल को हम लिख सकते हैं हम 1 by r square d by dr r square. Okay, so like del dot fr r cap can be written as 1 by r square d by dr r square f of r equals 0 because we know that f of r is solenoidal. Okay, so by solving this we can get that r square f of r is constant, like this whole term is 0 and we know that अगर हम कोई कांस्टेंट को डेरिवेटिव करेंगे तो जाके वो 0 होगा. That means r square f of r is constant. Let's take it c. So f of r can be c by r square. So from here we can see that f of r is proportional to 1 by r square. Okay, so here the option D, that is 1 by r square, like f of r is proportional to 1 by r square is the correct answer. Then for a quantum system, the equation satisfied by the probability density and the probability current density is called. The options are Hagen-Brooks uncertainty relations, Fourier's time independent equation, the equation of continuity, the eigenvalue equation. And here the option C is the correct answer, that is the equation of continuity. And we know this, that is del rho by del t plus del dot g equals 0. Okay, then question number 29. The biasing voltage for the base emitter junction of a transistor amplifier is chosen in such a way that the collector current flows from the entire cycle of the input signal. The amplifier can be classified as, and here the options are class A, B, C and AB. So here the option A, that is class A, is the right answer. And here is the last question of the session, and question 30. And here the question is, the headingular fringes formed in thin films are fringes of equal. I mean जो यहाँ पे fringes है वो मतलब किस basis पे equal होनी चाहिए. The options are thickness, inclination, phase and the intensity. And here the right answer is the thickness. Okay, so I hope you all enjoy the session. So for more videos, please do like, share, and subscribe. Thank you.